My dear students, we are going to learn Chapter 6 from Geography, Remote Sensing. See, all of you like photography. Even we likes to take photos of lower elevation from a higher elevation. So my dears, this lesson, it is something more interesting. It is about remote sensing. Okay. If I explain about a place, for example about Himalaya, I want to tell Himalayas, it is the mountains, the top part it's snow-clad mountains, then I want to explain and explain. But by seeing the picture of Himalaya, you will get a better idea of Himalaya, how it likes. So, remote sensing means by 1960, in the older days, the data collection is very difficult because we want to give the data through orally. But by 1960, the photography developed. Actually, it made much changes in data collection. Then later, 1960s onwards, we started collection of data using satellites. So what is remote sensing? It is the method of taking information about a place, phenomena or object with the help of satellite which is not in actual physical contact. Okay. So, for example, the picture of cyclone. Okay. All these pictures are taken with the help of satellites. So, like that data collection. So, the method of taking information about picture, place or phenomena with the help of satellite which is not in actual physical contact. That is called remote sensing. Okay. The instruments used for remote sensing is called sensors. Cameras and scanners are the two important sensors. Okay. Cameras, they collect photo when the light reflected off. And same time scanners are the sophisticated instruments that record electromagnetic radiations. See my dears, based on light, the remote sensing is divided into two, active and passive. Active remote sensing. Remote sensing with artificial light is active remote sensing. And remote sensing by using solar energy is passive remote sensing. Okay. And in remote sensing, the surface where the cameras or scanners are placed, it is called platform. We require some place to keep these cameras or scanners. That surface, see in the class here it's the platform where I am standing. So in remote sensing, the surface where the cameras and scanners are placed, that is called platform. And based on platform, the remote sensing is divided into three: terrestrial, aerial, satellite. Terrestrial photography means taking the picture of a lower elevation from a higher elevation. For example, taking the picture of sea above a rock. That means taking the picture of lower part of earth from the earth itself, or from above the tree, taking the picture of a field or something. Okay. So, taking the picture of earth topography from earth itself, that is in the land itself, that is called terrestrial photography. Next, it's aerial remote sensing. In aerial remote sensing, the platform, that is balloons or helicopters or drones, parachutes and all. Because the cameras or sensors are placed on balloons or helicopters and all. Okay. But it gives continuous data because it gives the data where the helicopters or the balloons it move. Okay. But the main technique used in aerial remote sensing is overlay analysis. My dears, overlay analysis means, see if it is the path of that helicopter, the first photo may be taken from here and it covers this much area, and the second picture may be taken from here, but it contains the 60% of the previous picture. And the picture C, it contains the 60% of the picture B. So this technique, taking the majority area of the later picture, it is called overlay analysis. By doing so, we will get a three-dimensional image. We will get continuity of the photos. And the instrument that gives three-dimensional picture is called stereoscope. And two such adjacent pictures are called stereo pair. But my dears, there are many demerits for this aerial remote sensing. First of all, we are using helicopters. It is very costly because the aviation fuel and all, it's very costly. And it needs large area for taking and landing. Often, the shaking of aircraft, it affects the quality of pictures. Okay. Not only that, repetitive data collection is not possible because it is taking the pictures the way it is going. It is not possible to take the previous picture again. So, repetitive data collection is not possible. So, to overcome the defects of aerial remote sensing, satellite remote sensing started. Two types of satellites used, that is sun-synchronous and geostationary satellite. First, geostationary satellite. Geostationary satellite, these satellites rotates with Earth. Okay, so these satellites along with Earth with an elevation of 36,000 kilometers above the Earth. So 1/3 of Earth under its purview. Okay, so just 3 satellites or 4 satellites needed to cover the whole Earth because it is too high from the Earth. Okay, so majority of Earth, portion of Earth under its purview. It is mainly used for weather studies and telecommunication. Okay, so because of this, repetitive data, continuous data, everything is possible. And the speed of Earth, speed of this satellite is same as the speed of Earth. So when the Earth rotate along with the same speed of Earth, they also rotate along with Earth. Okay, the best example for geostationary satellite is INSAT. Next is sun-synchronous satellite. These satellites revolve from the North Pole to South Pole along with the Earth. But its field view is very less because it is placed just 900 to 1000 meters above the Earth. Okay, but the field view is very less, but repetitive data collection is possible and it gives more clarified pictures. Actually, sun-synchronous satellites more used for satellite remote sensing. The IRS series is an example for these satellites. Okay, next we want to learn the uses of remote sensing. Okay, the uses of remote sensing. It is used for oil exploration, weather studies, and also to know about the natural resources, for planning, to know about the major climatic changes. So, it is very useful. Okay, next we want to learn about GIS. GIS, these are some softwares that help to make changes in map, edit the map, incorporate more details into the map, and to make new map and to change the maps into tables and also for thematic studies and all. Okay, so GIS is the software. Okay. So, my dears, in GIS software, we need 2 types of data. Okay, that is spatial data and attributes. Every object is added according to its latitude and longitude location. It is called spatial data. Attributes include the additional information regarding the ownership and the length and all, the additional information about the object. Then we will get information on like layers. Okay, so whatever matters, if we enter all the matters into that map, if we want to know how many CBSE or state board private schools in Edapal subdistrict, then easily we will get the answer in the form of layer. Or if we want to know the mountain ranges of India, that layer also it will come. Okay, it helps more in thematic studies. 3 types of analysis using GIS. Okay, network analysis, buffer analysis, overlay analysis. Network analysis, the linear feature, rail, road, water and all under analysis. It helps to get the shortest road, road without toll and all. Then buffer analysis. Buffer analysis, the activities around a point of activity and the distance to the nearest linear feature. Then overlay analysis, it helps for a comparative study. What are the changes now and what are the changes it undergone over a period of time. For example, if we want to know the extent of cultivation in our locality in 2000 and in 2020. So it easily we will get a comparative study. Okay, next part is satellite-based remote sensing, navigation system, satellite-based navigation system. Here we want to learn about GPS, the global positioning system of America. Okay, so long back we used to find way by asking others. Now the Google map is helping us. Okay, here we want to know how it is happening. The GPS, global positioning system. See my dears, 24 satellites are placed in 6 different orbits between the elevation of 20,000 and 20,200 kilometers away from the Earth's surface. So if we put the data in the handheld device, it will go to that satellite. Minimum the 4 satellites want to respond. Then it give reply on the basis of latitude, longitude, elevation. Okay, then that satellite respond according to the latitude and longitude and it display the result in our handheld device. Nowadays, more satellites are used to get accuracy. I think it's clear for you. So, the remote sensing. Okay, fine. My dears, learned the topic very well. Thank you.